Well, you're on the way, so just walk and.
Can everyone hear me? Okay. Why isn't this sharing? Come on. Why aren't you working? Duke.
That's it. Done. Okay.
Oh, there we go. Okay, can everyone hear me? Okay, great. Zoom just like froze for a little bit. Alrighty. Your test grades were out on Thursday or Friday last week. So the median grade was a 73. So that kicked in. Test corrections for everybody. So I posted those. I'm giving you guys until Friday to do those test corrections. Please follow the submission instructions of like like you can't just like do the problem again. So like follow the submissions and instructions. If you're curious about like what parts of the problem, you don't have to do like the whole so there's like some problems that are like A, B, and C. If you got part A full points on, you don't need to do that. But if you want points back on part C that you maybe got like half the points back, you can just do part B. So the point distribution and comments are found if you like go into that, like you submitted it and you click onto it. I don't know if you can go through the grade book to find it, but I just know if you go to like assignments and click on your submission, it'll break it down. And then if you are still wanting more feedback on your test, email me or come to office hours. Homework 5, part A and B is going to be due Thursday. So you have homework again. That's going to cover the things that we talked about the last 2 Tuesdays. And since you all filled out that survey from last time, a lot of you said that you would like if office hours were changed to the hour prior to class. So it's now from 3:30 until 2 or 4:20. Basically, give me like 5 minutes to like prep for class. And that's updated on the syllabus and posted on Blackboard. So if you forget, always check the syllabus. Okay. Anyone have any questions about anything right now? So I forgot to write our to-do list. So we're gonna finish 1.7. We have like one more problem there, which I left so that we could kind of have a recap because I knew it was gonna be like a week since I'd seen you guys. Okay. So with that, I don't think anyone has any questions. So let's move on to 1.7. All right, so remember 1.7, we kind of just talked about what information we can get from a graph. And we ended on talking about local maxes and minimums, right? So the function f of a is a local minimum of f if f of a is greater than or equal to all of the other outputs around a, right? Usually in between an increasing and decreasing interval, right? Because those intervals, we don't include those endpoints. Remember, this is local minimum, maximum, and minimum. So I'm just looking at x values near a. So I'm not looking for like the president. I'm looking for like the town mayor. Okay. The function value f of a is a local minimum if it's the opposite, if it's less than or equal to all of the other values around it. And then we talked about the difference between them, and we did this cute little problem where we found the local mins and the local maxes, and then we did an exit slip. So don't need my exit slip in here. All right. So now we're given, instead of just like, here's a function, find the mins and maxes, we're given a real life problem. So a highway engineer develops a formula to estimate the number of cars that can safely travel a particular highway at a given speed. This actually does a lot with the research I do about modeling how fast birds go around each other, flocking. It's pretty cool. So we're given n of x. So at what speed is the maximum carrying capacity or the road achieved for the road? I knew I had to spell it. For the road achieved, and what is the maximum? I think I meant minimum, maximum. Oops, let me go down to my personal notes. Oh, at what speed? Okay, yeah, sorry. At what speed is the maximum? What I like to do is highlight things so I don't get stuck like that. So what speed is the maximum capacity? And what is the maximum carrying capacity? So carrying capacity here is like phrased as the output, right? The road can only carry so many, right? So many cars can only fit in such small area going at such fast speed. Usually the faster you go, the kind of farther you want to stay away from a car for accident sakes. So how can I find my maximum? I'm just given an equation. So like, what should I do? You all said you could hear me. While I'm thinking. How do I know to find the maximum then give an equation? Okay. I don't ever notice if you guys come in late or leave or whatever. So no worries on that. Excuse me. Well, what have we done in the past? Every time we've been given an equation, we graphed it. So let's just graph it. I'm going to go over to Desmos calculator and, oh, that was from your homework. Don't look at that. Or look at it, I don't care. So we're given, what was it? 88 times x, and then divided by 17 plus 17 parentheses x divided by, oops, x. Oops. Okay. I want that spot. 20. What was it? 2 squared. Great. I'm gonna zoom out just because that'll help me figure it out. So we were told, let me take a screenshot of this. I'll go back to our notes. So we're going to want to graph our equations first. So I'll pop in here, show off my fancy graph that I just made. And there's kind of something that I need to, I'm just plugging in a graph right now. And remember how we talked about domains and ranges? When we're given this function, I'm kind of also given a domain of x, right? X is the speed. Can x be a negative number? If x is the speed of a car? No, right? In some cases, right, if you're like talking about distance of going back to something, but on the highway, I don't really recommend driving backwards. So we're like not even going to like think about this little bit that's down here. It doesn't exist in our world, right? So I'm just looking at from 0, 0 on. So from here on. So we're asked to find, the thing I like about Desmos calculators, it gives you like important points. So at what speed is the maximum carrying capacity for the road achieved? And what is that maximum carrying capacity? So looking at this graph that I just showed you guys, what is our speed, our speed where the maximum carrying capacity is at? What do you guys think that's gonna be? Can you guys see how big is that? Like zoom in. So what's the speed? Careful. So, oh, at a given, yeah. So a highway engineer develops a formula to estimate the number of cars can safely travel a particular highway. So N is the number of cars and X is the speed. Would you all agree? Right, how fast they're going depends on how many, or would affect the number of cars are on the road. So yeah, right, at a given speed. So X equals the speed, N of X equals number of cars. Also, remember how I always say like mathematicians like to name functions by the like first letter of something? The number of cards number starts with N. So it's another kind of giveaway that N of X is the number of cars. Right, so what speed is the maximum carrying capacity? So I would say like 20. I'm not given, just assume miles per hour. At what speed? So I would say like at 20 miles per hour. Max, yeah, is at X equals 20. That's a good way to say it. I was trying to say it the other way, right? And then, and what is the maximum carrying capacity? So the max is at X equals 20, where N of X equals that 51. Oopsies. All right. So remember, our output is going to be the actual maximum value. And then we're sometimes also going to be asked to tag along with, what was I going to say? That tags along with the maximum. So the X value that attaches to it. Wow, I just really My brain went blank. Okay, so we can say the max is at x equals 20, where n of x equals 50. Or we can say like the max speed is 20 miles per hour. I'm just assuming miles per hour with a carrying capacity of 51. What was the number? 76.5. This is a question for your textbook. It's not really my favorite. I would have definitely phrased it differently. And I think we actually are going to talk about carrying capacity in a few chapters, which is really exciting. Alrighty. So I left that question so that we'd have something to talk about in the beginning of class. Does anyone have any questions about mins and maxes and finding them, or local mins and maxes and finding them on a graph? All right. Once you guys get to calculus, you're gonna learn a lot of different ways to find the mins and maxes on a function without using a graph. It's really exciting. This is why this class is kind of important. It's very important. Okay, so we are done with that one. Now we're moving on to my favorite section that is not loaded right now. Are you hecking kidding me? Seriously? It was loaded like 10 minutes ago. Just give me a second. One second. Oh, I can pause share. Okay, 1.8. What's today? Tuesday, March 2nd, 2021. It's March again, everybody. All right, so this section is called modeling real world relationships. This is kind of where we haven't really done a lot. I mean, we've done word problems like when we did piecewise functions, but this section is all about modeling real world relationships. So there's no definitions or steps to do this, that, and the other, right? You're going to have to use a lot of knowledge that's expected from you, right? Like the perimeter of a rectangle. I highly expect that you guys know that. How to like shapes and stuff, right? Circumference of a sphere. Circumference of a sphere. Surface area of a sphere? Probably not. But stuff like that, right? Like I expect you to know how to find the perimeter of a shape. So that's kind of what this is really about. This chapter is also heavily relied upon in calculus on the problems that are called optimization problems. So in finding the mins and maxes of something, you're like optimizing it. So a good example is I have this much material, and I want to optimize my profit. So doing that, I need to save on material. So I want to have enough volume, but save on my surface area so that I have can save on like making it, something like that, right? So boxes, we'll work on that a lot. Talking about baseball caps right now on this first problem. So this This is one of the harder sections in the whole course. My students last semester were kind of quiet and fine with it, but if you guys are having any, I don't understand that step, I want you guys to be vocal about that, just because this is kind of a more difficult section. It's my favorite section because it's about real world relationships, so applied problems, and I'm an applied mathematician. So this is like my field. A lot of the times you might be given two different variables, so something and something else, and you just need to put it into like one bigger thing, right? Like I think this one. There's just going to be a lot of different types of problems. Okay. I'm just really excited about this section. So so this is just going to be a whole section on examples, right? So we're given that a company manufactures baseball caps. Super cool. They charge a fixed fee of $500 for setting up the machines and $8 for each caps to produce. If you've ever ordered t-shirts for any organization, you know how this works. I had to do t-shirts one time and it was awful. So find a model for the cost of purchasing X number of caps. Okay. So what should I name my function to model the cost of purchasing X number of caps? I like to call it C of X, right, Griffin? So we're going to call it C of X. I'm charged a fixed fee of $500. So cost, I'm going to just add up all my individual costs, right? So I'm going to have that fixed fee plus the caps. I want to say the cost of the caps, right? I'm not just paying for the caps. I have to like pay for something else too. Look at like carps. Carps used to be my favorite fish. I had like a fish book growing up. I really loved reading it. Okay. So my fixed fee, that's going to be 500. I'm told that. This isn't always what cost is going to be. It just depends on the problem. This is where I highly suggest highlighting or underlining problems. So I have 500 and then $8 for each cap produced. Every time you see a number written in a word problem, underline it. Rule of thumb right there. So how I know a fixed fee is just $500, but the cost of caps, that's going to depend on the number of caps, and I denote that X. So how can I represent my cost of caps if they're $8 for each cap? Okay, Ron changed his answer. It's 8X, right? So if it's $8 per cap, I'm then going to multiply it by the number of caps I have. And that's how I'm going to get my function. Cute little functions, right? So how much would 225 caps cost to produce? So number of caps, right, is my X value. I'm told that in when I find my model. So I'm trying to find C of 225. So I'm going to plug that into my model that I created above. Wherever there's an X, I'm going to put a 225, which is the really great thing about using function notation, which we talked about in chapter 1.5. I'm going to plug this into my handy dandy pre-written notes, and it's going to give me the answer out that I want. $2,300. Excuse me. Right? That wasn't too bad. Right? How are you guys feeling so far? Right? So, right, there was no, how do I know what like is cost? I have to look at the problem, assess, what am I, like logically speaking, what am I gonna have to pay for? Definitely have to pay that fixed fee. They charged me for it. I should pay it, and so on. Okay. Oh my God, this is like the craziest problem. Your book has like a whole paragraph on talking about paper. It's really funny. So the average US resident uses 650 pounds of paper per year. I don't know how that's possible. The average pine tree produces 4,130 pounds of paper in its lifespan, right? Chop down the average pine tree, it's going to give you that many pounds of paper. Wild. So we're going to find a model for the number of trees used for paper in 1 year by ex-US residents. That seems so confusing. I'm given two numbers and they're different units, right? This is 650 pounds a year. And this is just straight up pounds of paper. So I have 650 pounds a year. That's going to be like the average person. Let's call that A. And then the average pine tree. God, why is everything? Let's call it this resident, R for resident. And my average pine tree produces just 430 pounds. Okay, so I'm finding a model for the number of trees used for paper in 1 year by X amount of US residents. So since we talked about independent and dependent variables, what is he? X US residents. That's my independent variable. So independent variable, that's going to be X. I'm looking for the number of trees. Let's call that T for trees. So I have T of X. That's my model, okay? So I want trees out. So what am I going to do? X is somewhere in here. What am I going to do with 650 and 4,130? I want to give you how many people there are, and you're going to spit out the number of trees used. So what are we thinking? Since we're in 1 year, this isn't really over a year. So we have 650 pounds and then that per one tree. I don't know. How much did you miss, Griffin? The lectures are recorded. So, oh, okay. So we're trying to figure out what to do with 650 and 4130. Abby says 650x divided by 4130. Abby, how did you get there? Griffin agrees. Why wouldn't it be the reverse? Why wouldn't 4130 be on top and 650 on the bottom? This one's a little tricky because there's lots of words going on. I don't know if you're typing or not. Okay, so, right, so yeah, 650 kind of, when I think Abby says goes with X, it's multiplied by X. So it's, if you guys ever heard of directly and indirectly proportional to, directly proportional in the numerator, indirectly in the denominator. since this is talking about how many the residents use, if I can just work on bits. So this 650 times X is going to give me the total amount of pounds of paper used across the whole US, right? Just similar to how I multiplied 8 by X before. That was like per person, right? And then I'm going to divide by how much is used by one tree. Because I want trees back out. If you want to think about it, I'm doing like pounds divided by pounds per tree, which is like the same as saying like pounds is an equal times trees over pounds. And you just get trees back out. If anyone's ever taken a weird physics class where you just had a weird unit on unit conversion, this is really helpful for that. And I talk about unit conversion a lot because it's just a little trick to help know if I'm multiplying or dividing things correctly. Because I know I need to get trees back out, number of trees. So I don't want 1 over trees out. Does that make sense? Okay. How are you guys feeling about this model? You guys are tired today, I guess. Okay, I'll take it. So, yeah, right. It's definitely it's phrased very dramatically. So yeah. All right, so in 2013, the city of Cleveland Heights, Ohio, Ohio, had a population of 49,000. How many trees did Cleveland Heights residents use in 2003? So our population is 49,000. So, oh, I'm sorry, Anna. I'm just from Virginia, and I think Virginia and Ohio have beef. Nothing actually against you. Anyways. Okay, so my first job out of college, they had our first work trip that people like got to go to. They were so excited. It was to Cleveland, Ohio, and I just thought that was like really funny. So how many trees are Cleveland Heights residents using in this year, right? If there's 49,000 of them. So I'm going to put 49,000 in for my number of residents. And then what is that? What was it? 650? Yeah, 650 times 49,000 over 4,300. Also, we can cancel out a 0. So I'm plug that into my handy dandy calculator, and I'll get somewhere around 7,693 trees. The reason I rounded is, I think I've rounded. Some answers make more sense giving whole numbers if you think about the context, but trees I would understand. But if once you chop down a tree, you're kind of using the whole tree at that point. Yeah, I'm rounding. Yeah, you have to cut the whole tree down. What number did I mess up? I too got that number. Okay, got that too. Thank you, everybody. Calculator. No idea where that other number came from. All right. So easy as that. You just need to give units right here, especially in this section. Units on, if I'm asking this much population and you're just supposed to give me an output, I need units. You're always going to be given units. Give me units back. I need units. It's part of your answer. Okay. So how are you feeling about this paper problem? Got it. Oh, did I write? I meant 12. I would round up. And we're not going to get into the specifics of rounding. This is not a chemistry class. And if I ask my boyfriend about it, he'll talk about it for like 30 minutes and I don't care. Something with like something if it's 5 and then it's an odd number. No, I do not care about sig figs in math. Sig figs do not exist. No sig figs. Usually, I usually give 2 to 4 decimal places if reasonable, right? Like in this case, I cut down the whole tree. I need to use that. I don't understand sig figs. I literally haven't taken a science class since high school. I do not know them. Okay. AP chemistry really got me out of labs in college. God bless. Okay. So moving on. Gardening. So a gardener waters his vegetable plot using a drip irrigation system. Wild. I have no idea what that means. Water flows slowly from a 1,200 gallon tank through a perforated hose, not house, hose network. They really just put some detail in this problem. To keep the soil appropriately, God, Mackenzie, spell something right, moist. During the spring planting season, the garden requires 80, my God, okay. I definitely wrote this last semester when I was like really tired. Gallons of water per day. So I have a 1,200 gallon tank. And during the spring planting season, when I'm using it, it requires 80 gallons. I'm going to use 80 gallons every day that I use it. Okay. So I'm going to find a model for the amount of water that is in the tank X days after it has been filled. I'm assuming that just to save myself time, I'm going to only fill it once it's empty. Okay. That's just kind of an assumption we have to make. I know, no assuming, especially in mathematics, but that's kind of just like an assumption. If we're not told, it's not happening. So what should we call our model for the amount of water in my tank? Call it W. W of X, right? So, and it's X days, and it's gonna represent the amount of water that is in the tank X days after it has been filled. Okay. So how much is going to be it the day I fill it up? So at day 0, 1,200, right? So I'm going to have like day 0 amount plus the day before. Oh my gosh, who is that?
Let's go.
There we go. Okay. Oh. Yes, we are going to subtract because water is being taken out of the gallon. Right? So whatever I start with, which is like the maximum amount of water that I can hold. Oopsies. So 1,200. And then since water is being taken out, I'm subtracting. So I'm taking away. What's this portion going to be? If I'm every day after, 80 gallons per day is taken out, right? 80x, that multiplication again. Oops. And there we go. So now kind of what I talked about earlier with actually the first problem that we did today in 1.7, there's an implicit, almost like an induced domain, depending on our problem. Yeah, that function, I can put in any X and get a number back out, but does that output logically make sense in the term of this problem? If it doesn't, then it's not in our typical domain, okay? So how much water is in the tank after 3 days and then after 12 days? Using function notation, how would I represent finding the amount of water after 3 days? We called our function W. So what would I say if I was finding W after 3 days? Hope that made sense. I don't think it did. So I would write like W of 3, right? Because X is the number of days after it's been filled. Yeah, X equals 3. So you do 1200 minus 80 times 3. And that's going to give me 3 times 8. Oh my God, I hate 8s. 16, 24. So 240, which is equal to 960 gallons. Don't forget my units. And then W of 12. What would that give me? 800, it's a 0. And then 160. That is not 8 times 12. Is it? Huh. Okay, cool. So, and that I know is going to be 240 gallons. All right, easy as that. Get your brain going, doing some mental math. Cool, so I can last nearly like 2 weeks without filling up. That's great. So now we're asked to find and then interpret W of 20, right? So now we're not, earlier we were just told to find these values at 3 and at 12. And now I'm asked to also on top of that interpret what that result means. Usually means that there's probably an interesting answer going on. So W of 20, I'm gonna just keep doing what I've been doing, plug and chug. Oops, forgot my throw. Which is gonna give me 1200 minus 1600, which is gonna give me negative 400 gallons. How can I interpret that result given a negative amount of gallons? How would you tell the farmer what that means? Very empty, right? I would say that it's too empty. I wouldn't say after 20 days. I would say before 20 days. Yeah. I would. So the tank, I would say is 400 gallons short. Or you could say like, I would need 400 more to be able to water the garden for 20 days straight. Short. Without filling up, right? All right, cool. So how many days will it take the tank to be empty then? Plants are thirsty. So, Ronald, how do you know that? What did you do? Can't just tell my answer. How do I find that. So far, I've just been plugging in things for X. So would I just plug in 0 for X? Right, I want to set equal to 0, right? So how many days for it to take the tank to be empty? Tank to be empty would mean that WX equals 0 gallons, right? So I would take my 1200 minus 80x equal to 0, and you guys are champions at solving equations. So I have 1200 equal to 80x divided by 80, divided by 80, or 120 divided by 8, which would give me 15 equals X. So I would say 15 days. Okay. $15 dags. So it's quite convenient that it's exactly 15 days, but this is maybe a case where I would round down. So if I had like 15 and a half days, halfway through day 14 or the next day, 16, I would be like, ooh, I should have filled up water before. I like don't have enough for tomorrow. If I only have like 40 gallons or something. But we got a whole number, so we don't have to worry about rounding. Okay. So the gardener prefers not to let the tank empty completely. Fair. Instead, he decides to refill it when the level has dropped to 200 gallons. After how many days should he fill it? So what equation would I be solving in this situation? Am I going to plug in 200? What am I going to do? Oh my gosh. There we go. Now I'm going to set to 200. Exactly. So now I have 1200 minus 80x equal 200. So I'm going to move my 200 onto the other side and also add 80x onto the other side, getting my variable alone and putting all my constants together. So I would have what, 1000 equal to 80x, right? 80, and that's going to give me x equals 12.5. So I guess he could, like, halfway through his day just say, maybe I do want to fill up. I really just, I want to get to 200 gallons. Not after 200 gallons, just exactly at 200 gallons. Once it's there, I'm going to fill up. So it seems like he's pretty okay with taking his lunch break to fill up. And so I can take 0.5 days. That's fine. Oh. Drop my pen on my iPad. Okay. How are we feeling about the gardener and his water tank right now? Thumbs up, thumbs sideways, or thumbs down on gardener guy. The hardest part of these problems is making the model and being able to interpretate the outputs correctly. Okay. The next problem is all-time favorite problem. It's my favorite problem in calculus. My 141 students always have this. But you're getting the non-calculus version of it, right? Another thing that really helps with these types of functions is to draw a picture. The gallon one wasn't really helpful, but when we're talking about like a rectangular vegetable garden, it's sometimes helpful to like visualize it, and it's sometimes hard to visualize something and your brain will also think about math. So just like draw a picture. Oh wait, this is not my favorite. Okay, it's close. So a gardener has 140 feet of fencing to fence a rectangular vegetable garden. So let's draw our little garden. Actually, I think this one is really, wow, this is like not a good rectangle. Okay. I act like that's a rectangle. Actually don't, because I'm really embarrassed by that. Oh, yes. Okay, there's my vegetable garden. Here are some little pumpkins. Some red bell peppers. And some blueberries. They're not vegetables. Actually, neither are pumpkins. Actually, it's a squash, so I don't know. That's my vegetable garden. It's rectangular, so that means that this side and this side are equal, and this side and this side are equal. So sometimes you'll see like little lines like here, and then this double line to just pair them up that they're the same length. Okay. I have 140 feet of fencing that I can wrap around it, right? I can move this rectangle to be like really, really skinny and long, or a square, that's still a rectangle, and so on, right? So I want to find a function that models the area of the garden she can fence. So this is I was kind of talking about earlier, sometimes you might have multiple variables. So like I have this width, I'm going to call W, and then I have this length, I'm going to call L. And now I know that I have 140 feet of fencing. Is that I only have two equations that I know to do with rectangles, area and perimeter. Is 140 feet dealing with area or perimeter? What do you guys think? If it's fencing, it's perimeter, right? So I'm going to use all of my fencing, right? I have it, not using all of it. I want the maximum amount of, I probably want the biggest area. So I'm just going to use all of my fencing. So, and that's going to equal my perimeter. So let me write that my perimeter is a rectangle we know is 2 times the length and 2 times the width. And then I just found out that that is going to be 140 feet, right? But I was asked to find a function that models the area. And I only know how to deal with functions when there's one input, one variable, right? I have W and L, and that equals 140. And my width and my length, well, that's not my area. What's the equation for the area for a rectangle? Yeah, width times length. So I don't have a function right now. I have a function of one or two variables, W and L, but we only know how to deal with it with one. So this is where this second equation comes into handy. So I'm going to use the other equation. And I'm going to solve for a variable. It doesn't matter which one, as long as you just announce your or present your model in a concise way. So what should I solve for in this equation star? Should I solve for W or solve for L? Doesn't really matter. I just want someone to tell me. W, right? So if I solve for W, I'm gonna do that off to the side. So 2W plus 2L equals 140. I want equal to W, so I want W all by itself. So I have 140 minus 2L, and then I'm going to divide everything by 2. And that's going to give me that W equals 140 minus 2L over 2, which I think is also just 70 minus L. Let's just call it that. I hate fractions, especially when you don't need them. Is everyone okay with how we got 70 minus L is equal to W? Okay, cool. So I'm now going to take this and plug it in right here. So A is going to be equal to, instead of W, I'm putting 70 minus L, and then that times L is just going to stay. And then if I wanted to, I'm going to say this is equal to distribute my L. So it's going to be 70 L minus L. And usually when we write models, I want to say what my input is. Earlier, I really couldn't say because I had two variables. I had W and L. But now that I just have L, A turns to A of L. Oh my God, L squared. Thank you. Right? So this is going to be my model. I wasn't really told which one to focus on using L or W. So I just chose to go with L. Okay, how do you guys feel about getting that problem, that model, excuse me? Thumbs up, thumbs sideways, or thumbs down? Okay, cool. They're a little difficult. Practice makes perfect with these. And that's what homework's for, and office hours. Just know if I have two variables, I'm most likely going to have two equations. One that's set to a number that's not going to move. Sometimes I might have a set area, and I'm going to be asked to model perimeter. So I'm going to use that second equation to get my two variables in terms of one of the other. Sometimes it might matter if I'm asked to do one way or the other, or I can just choose one like I did here and to get an equation with one way. I'm going to have an assist equation to help me out. Okay. So for what range of width is the area greater than 825 feet squared? So I'm asking range of width. Did it tell me which one to use? So I found L. So what range of width? Ooh, you know, we can do this without changing our model. Okay. So let's remember, let's just keep in our toolbox that W equals 70 minus L. Okay. That would also mean that, what would L equal? L would equal 70 minus W, right? If I add L to one side and subtract W. So that would mean that I could write A of L, which is 70 L minus L squared as 70 W minus W squared equals A to W. Same way of writing it. Okay. You can't always do that. It just happens to be that since L is 70 minus W, once you like plug all of this in, it'll make sense. Okay. So I want to find the range of the width. So range of width, that's going to be like an interval of W's. So like X values, like inputs. Is the area greater than 825 feet squared? So I don't know how to figure that out. So let's go look at our graphing calculator. Okay. So open up Desmos. I don't need you anymore. I'm given 70x minus Actually, I don't think that's the same equation. X squared. It should be the same equation. Okay. There we go. What is it? 825. Okay. So this black line here is 825, right? So let's look at boop, 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 boop. Come on. Okay. If you hold the axes, it helps you squish them more. There we go. Okay, take that, move it into my notes because that'll help. Okay. Whee. Okay. There we go. So, one second. Okay. Jeez. Okay. I need to make sure something's right. All right, cool. So I want to find the range of the width, the area that is greater than 825 feet. So if I zoom in on this little photo, my little graph, I can see at 825 feet. So from here to here, my graph is over 825 feet. Whee. Remember, my input is W. So between, I want greater than, not greater than or equal to, so greater than 825. So I'm not going to include that one. So my hand is killing me. I can write something like this is the range of widths used for the area to be greater than 825. All right. So you will have to use a graphing calculator on some of these problems. You're like, oh, what is that? Oh. What's another way of doing this problem without using a graphing calculator? I kind of gave that away. Oopsies. What's another way of doing this algebraically? So by hand. Griffin says he can do it. What if, so right, I'm trying to find the area is greater than 825. Delete this. I think I did this last year, right? Did not mean to use the graph, and I did because I was like, haha. There we go. 825, and then I can plug in, what was it? What was my function? Oh, it's right there. 70w minus w squared greater than 875 or 825. We can solve a, this looks kind of confusing, but what if I wrote it as nope, not that way. What would it be? W squared minus 70w plus 825 greater than or equal to 0. Would y'all be able to solve that? I hope so. It was on your exam, right? I would want to find the zeros first, right? Which we saw was at 15 and 55. And then, right, I want to test points in my interval, right? So so I found 15 and 55, and then I plug in numbers like 0, 20, not 500, maybe 56 if I wanted to. And that would give me negative values, positive values, and then negative values. And I want only positive values. I don't want that to be included. There we go. So I would choose this interval. On your exam, a lot of you guys were just like, yeah, here it is, the answer. I factored it, but then here's this random interval I found and didn't show me how you got that you confirmed it was that interval. So you need to confirm by using test points in each of the intervals created by finding when it's equal to 0 and moving on. All right. I just tricked my answer by graphing it. Okay. No more graphs. Okay. So can she fence? Okay, wait, first of all, how's everyone feeling about this part B? Like meh on it, right? You guys should be pretty bomb at solving nonlinear inequalities because it was on your exam. Quick, yes, test corrections are due Friday. If you're ever confused when something is due, it says on the assignment. So just go to the assignment page and click there. So can she fence a garden with the area of 250 feet? So I can use AL, AW, let's just do AL. So can AL equal 250 feet? Griffin says no, why? That's true, that's the max, but if I weren't looking at a graph, how would I figure it out? Remember, we're in the real world. We can only have real solutions. So I'm given this quadratic and asking it basically if it has real solutions. What is a quick way to figure out the number of real solutions a polynomial has or a quadratic has? The quadratic formula, there's another tinier part of the quadratic formula that would tell us a lot faster. Yeah, what's that part under the square root called? Who knows it? Starts with a D. The square root is called, okay, everything under the square root is called the radicand. Yeah, it's b squared. Discriminant. Right, and that is b squared minus 4ac, right? Not discriminate. So what we're gonna do is b squared. It's b squared. So 70 or negative 70 squared minus 4 times 1 times 1250. Right, that's going to be the discriminant. What does that equal? 70 squared is going to be 49,000 or 4,900. And then minus, what is that? 250, so minus 500. So this is going to equal a negative number. What does that mean? I get a negative, I think like 100. What does that mean if I get a negative number in my discriminant? This might be more useful when we have the quadratic. Not that I'll be 100 feet short. Yeah, no real solution. Yeah, let me move the discriminant part. So no real solution. Therefore, she cannot fence in a garden that large. Great. And I'll be more specific on the homework and which parts, like you should use a graph here. You should try to not use a graph here. Why isn't the 250 negative when you moved it to the other side? I didn't move it to the other side. I kept it on that side. W squared, see, negative, just flipped it side. So I flipped the signs of these two guys. Yeah, but I like to read that zero's on the right-hand side. I don't know, you're fine. It's confusing when the equal sign. Okay, cool. How are you guys feeling about this one? It's crazy how things that we learned in chapters A, B, and C come back all the way here. So I read them first. Okay. So now we're asked to find the dimension of the largest fence she can fence. I don't know what that question I was asking is, but find the dimensions of the largest fence. So when you're asked these problems, you need to be really careful of like what you're giving. That's why I always say like I need units involved, because like I'm asked for the dimensions here, right? I have a function that's just with L or just with W. Did my pen just die? Son of a gun. So nuggets. Oh good, we only have 3 more minutes. When I'm giving dimensions back, I need to give W and L. Not just L, not just W, right? So you need to really read these questions really carefully. Let's see if my pen will turn back on. Heck, okay. We're gonna come back to that little smidgen part next time, just as a recap of what we did this time. Also because it's 2 minutes left, and I know we would get the largest one by like what, 125 feet? No, 1225. I think that's what Griffin said was our largest one. So we're gonna come back to this. Let me add. I can't even do that. Oh, I can do this. Okay. Yay. Oh, great. Can I draw with my hand? No. Okay, so we're gonna do an exit slip now because my pen died. Exit slip or exit ticket on Socrative. My pen is dead. What should our teacher question of the day be? Can I write with this thing? No. Who wants to give me an idea for a teacher question of the day? Ooh, I know. Actually, What is a good teacher question? That's not your question. Don't put that as your teacher question. How did you spend your wellness holiday? It's in the chat. So did you catch up on homework? Did you grade exams all day like I did? It was a beautiful day. Did you go hang out on the quad? If you did anything illegal, please do not tell me. Just like, how did you reflect? It is BLACK in capitals 943. It's Abby that usually types it. I'm trying to type with my finger and it won't let me. And then if you have any questions, I'll be here for a little bit. I'm gonna walk my dog. Duke, come here. Duke, Duke. Do you have any questions about the stuff that we talked about today? Oh, big shake. Up, up. You can ask. I'm gonna stop recording. Oh, big yawn. Thank you. Oh, that was a share. Where's my recording button?